All right, let's get right into it. For years now, we've thought of AI and software development as a kind of helper, right? A copilot. But something fundamental is shifting right now. We're moving from an AI that just suggests things to an AI that actually does things. We're talking about a brand new kind of teammate, and it is completely reinventing how we build software.
I mean, really, let that sink in for a second. This isn't about a slightly smarter autocomplete. This is about giving an AI a task and having it figure out the plan, write the code across a bunch of different files, run the tests to see if its own work is any good, and then come back to you. That is the incredible leap we are about to dig into.
So here's the absolute core of this shift. We're going from a copilot to an agent. A copilot is passive. It's an assistant that offers up suggestions, sure, but you, the developer, you're still in the driver's seat running every single command. An AI agent, on the other hand, is an active teammate. It has agency. It can run commands, and crucially, it can verify its own work. Okay, so here's our game plan. We're going to start by really defining what it means to go beyond the copilot. Then we'll dive into this agentic paradigm itself. We'll look at how its reasoning stacks up against older tools, see how it fits into a real-world pipeline, talk about the all-important human in the loop, and finally, look ahead to the autonomous future. First up, moving beyond the copilot. This is where we really leave behind the idea of AI as just a super fancy autocomplete and start treating it like a system that's capable of taking autonomous action. And the difference in philosophy here, it's just massive. Look, GitHub Copilot is amazing at what it does. It's basically autocomplete on steroids plus a chat function. But Claude Code is designed around a totally different idea, an agentic environment. Its entire reason for being is to plan and execute tasks. And with a context window of up to 1 million tokens, well, that's enough to hold an entire complex project in its head at once. It sees the whole story, not just the one page you have open. So we keep using this term agentic, but what does that really mean? What does it mean for an AI to have agency, to actually do something on its own? Well, that's the heart of the agentic paradigm. At its core, agentic coding is all about one thing: access. We're talking about giving an AI system the keys to the kingdom, the same environment a human developer uses. It gets access to the file system to read and write code, version control like Git to see the project's history, and the runtime to actually execute code and tests. This direct access is the secret ingredient that lets it work on its own.
So what does this look like in the real world? Well, it follows this really smart 4-step loop. First, it explores. It reads the whole code base to get the full picture. Then it plans, creating a step-by-step strategy. Third, it implements. It gets its hands dirty and writes the code. And finally, and this is the most critical part, it verifies. It runs tests to prove that its own work is correct before it ever comes back to you.
Okay, so we know what it does, but how does it do it? How do these agents think? Because this isn't just about being faster. It's a huge shift from simple pattern matching to a truly deep understanding of what the code is meant to do.
And this table, this right here, says it all. Traditional tools, so-called SAST tools, are based on rules. They're like a security guard with a big book of known bad guys. If your code matches a picture in the book, an alarm goes off. But an agentic AI like Claude is more like a detective. It doesn't just match pictures, it analyzes the business logic, it reasons about whether a security flaw is actually exploitable, and it can even tell you when your new code is starting to drift away from the project's core design principles.
The secret sauce behind this is something called neuro-symbolic reasoning. Now, don't worry about the jargon, just think of it like this. A traditional tool scans your code like a spell checker looking for typos. An agentic AI reads your code like it's a novel. It understands the plot, the characters, how data flows from one function to another. It gets the themes. And because of that, it can find these really complex plot holes in your logic that a simple spell checker would just fly right past. Okay, theory is great, but how do you actually use this stuff? Where does the rubber meet the road in a real developer's workflow? Well, this is where it gets incredibly practical, starting with something like automating code review. Check this out. This single line of code in a terminal, this is it. This is where the theory becomes reality. This command grabs all the files that have changed in your project, sends them straight over to Claude, and tells it, do a full security review. And just like that, you've kicked off a deep, context-aware security audit with a single command. And you can bake this right into your existing pipeline with stuff like GitHub Actions. All you need is an API key, a good, clear prompt, and, this is the really powerful part, a schema for structured output. This forces the AI's review into a clean, predictable format that other machines can understand. So now you can automatically create bug tickets or trigger other alerts based on its findings. Now, of course, with all this incredible power comes the need for really smart governance. This isn't about setting an AI loose and hoping for the best. In fact, the human becomes more important than ever. Your role just shifts up a level to oversight and strategy.
So how do you guide this powerful new teammate? You give it a constitution, a simple file called Claude.md that acts as its North Star. In here, you define the project's what, the tech stack, the file structure. You define the why, the big picture goals. And you define the how, the exact commands to build and test everything. This ensures that every action the AI takes is perfectly aligned with your team's goals. You know how sometimes you can get lost in the weeds on a big task? Well, an AI can too. It's a problem called agentic runaway. So there's this simple, elegant guardrail, the 2-action rule. After every 2 major steps, the agent is forced to stop, save its work, and reread the original plan. It's a built-in sanity check that keeps it laser-focused on the goal.
And this might be the most important rule of all: human accountability. The AI can write the code, but a person has to own it. Every single change an AI makes needs a human champion who can explain why it was made and take full responsibility for it running in production. This is about intelligent augmentation, not about blindly handing over the keys.
So where is all this heading? Let's look down the road a bit, toward this autonomous future where these agents stop being just tools and start becoming true engineering teammates.
The path forward is pretty clear. We're heading toward a world where you can give an agent a high-level task and it just handles it. Imagine filing a bug report that simply says, the login button is broken on phones. The agent could figure out the cause, write the fix, add a brand new test so it never happens again, and then bundle the whole thing up for one final human sign-off. That's the idea to code future. And you better believe this has massive implications, especially for security. We're setting a whole new security baseline. The reality is attackers are going to use AI to find vulnerabilities faster than ever. So defenders have to use these same agentic tools to find and fix those flaws just as quickly. It's becoming an arms race, and this is the new weapon of choice for defense.
Which brings us to one final big question for you. This technology is moving at an absolutely incredible speed. This isn't science fiction anymore. So as you think about what's next for your team and for your own career, you really have to ask yourself, is your next teammate going to be an AI